All right, so want to understand Bitcoin and blockchain.
Huh.
Well, today we're taking a deep dive into this YouTube video by Ricardo Calix.
Oh, yeah, I've seen this one.
He uses Python to kind of break down these complex concepts. It's like um, a crash course without the semester-long commitment.
Right, right. It's interesting how he uses Python to make it all, less intimidating instead of getting lost in the jargon.
Yeah.
He focuses on the core principles.
Yeah, and he doesn't shy away from the tech stuff either.
Yeah.
He actually walks through these examples using specific hash functions.
Mhm.
You know, SHA-256, right? PMD-160, like real deal stuff.
Yeah.
But here's the kicker. He actually had his students run like this mini mining simulation right there in the lecture.
Oh, wow.
Can you imagine?
That's cool.
Like actually doing it.
Yeah. And it wasn't just theoretical either, right? He mentions that some of the students' laptops actually overheated.
Oh, yeah, yeah.
During the demo, it really highlights the computing power, needed to mine Bitcoin.
Yeah, it really puts things into perspective. Like trying to solve a massive puzzle. And the faster your computer can crunch the numbers,
Right.
the better your chances of getting that Bitcoin reward.
It makes you think about, the economic and environmental impact of all that processing power
Yeah, yeah, definitely something to think about
as the network grows.
for sure. But let's talk about Bitcoin wallets for a minute.
Okay.
So Calix explains how they're generated using the thing called elliptic curve cryptography.
Yeah.
So kind of intimidating, but
It's a cool concept. Imagine this, complex curve, right? And each point is a potential wallet.
okay.
Through all these calculations, you get a private key,
Uh-huh.
which of course you have to keep secret. And that key unlocks the public key, which acts as your wallet address.
So like a secret code to get your funds.
Exactly. And Calix shows how a simple Python script can, do this whole process,
Yeah.
making it less like magic and more, logical steps.
Right, right.
And what's cool is even if someone knows your public key, they can't access your funds without that private key.
Yeah,
One-way street.
gotcha. So what happens when you actually want to send some Bitcoin?
So Calix breaks down the transaction process, makes it surprisingly easy to understand. He
Yeah.
uses this analogy, like paying for coffee with a $10 bill, right?
Okay.
You empty your wallet, $5 to the shop, $5 back to you, change, right? Same concept.
Makes sense.
It's like that with Bitcoin transactions.
Instead of cash, it's digital inputs and outputs.
Right, so your whole balance is an input, then part goes to the recipient, the rest back to you as change.
Interesting. Kind of counterintuitive at first,
Yeah.
but it makes sense.
It's key to the whole blockchain security and transparency.
Okay.
Every Bitcoin transaction is linked to the previous one.
So it creates like a permanent record.
Exactly. A digital chain of custody all the way back to the first Bitcoin.
Wow. That's kind of revolutionary and a little, well, unsettling.
Yeah.
On one hand, total accountability. Well, on the other hand, what about privacy?
Yeah, it definitely raises some questions about that balance, transparency versus privacy in this digital world.
Yeah. Now, this is where it gets really interesting.
Okay.
Calix says Bitcoin has its own, mini programming language built in.
Yeah. It's a set of commands called opcodes.
Opcodes.
Yeah, and they define the conditions and verification steps for each transaction, the rules of the game, basically.
And miners actually execute these opcodes to validate transactions.
Right. It's like having this network of auditors constantly checking everything.
Oh, wow. So they're not just theoretical.
Nope. They're essential to the whole system. And here's the thing. These opcodes can be used for way more than just sending Bitcoin.
Really?
Like you can build more complex financial tools, agreements, all secured by the blockchain.
That's mind-blowing. But hold on, before we go too deep into that, let's talk about digital signatures.
Oh yeah, crucial for security.
So Calix explains how they work using this algorithm called ECDSA, Elliptic Curve Digital Signature Algorithm.
A mouthful, right?
Yeah, but he breaks it down. Basically, it's like signing a document in the real world.
Right. Verifies your identity.
Exactly. In the digital world, ECDSA uses math to do the same thing. Your private key creates a unique signature for each transaction.
Which can then be verified using your public key.
So only the person with the private key can authorize a transaction.
That's the idea.
And Calix even shows this whole process in Python.
It's amazing to see these complex operations in, relatively simple code.
Yeah, it really is. So we've covered a lot here.
We have.
Hashing, wallets, even a bit of Bitcoin scripting language and digital signatures.
You're well on your way to understanding the basics now.
But we're just getting started.
Right. Welcome back. So last time we talked about how secure Bitcoin transactions are,
Right. Uh,
but how do they actually get added to the blockchain? That's where mining comes in.
okay, yeah. So Calix actually made this Python script
Yeah,
to like show the mining process.
right.
It's simplified, of course, for the demo, but it captures the key elements.
Yeah.
So he starts by defining a block, which
Mm.
is like this container for information,
Right.
transaction data, timestamp, reference to the previous block, all that.
And that's what's so cool, right? These blocks form a chain,
Yeah,
each one linked to the one before it, like a chronological record.
and that's where hashing comes in again,
So
right?
absolutely.
Yeah.
Each block gets hashed, creating this like unique fingerprint
Okay.
ensures the data's integrity. Change one tiny thing,
Uh-huh.
the hash is completely different.
So it's like tamper-proof.
Exactly.
But Calix also mentions this thing called mining difficulty.
Yeah.
What's that about?
So mining difficulty, it makes sure new blocks are added at a steady rate,
Okay.
like a control mechanism adjusts the complexity of the puzzle miners have to solve.
He even shows it visually, right?
Yeah.
With like the leading zeros in the hash.
Yeah. The more zeros, the harder it is to find a valid hash.
Makes sense.
And that's where all the heavy lifting comes in. Miners are competing, trying to solve this puzzle,
Uh-huh.
using powerful computers to hash the data over and over.
Trying different values until they find the right one.
Exactly.
Calix uses a while loop to show this,
Right.
the brute force nature of it.
Keeps hashing and hashing until, boom, there's the solution.
And that's why those laptops were overheating, huh?
Yeah, exactly. It takes a lot of energy, resources.
And that's why miners get rewarded with Bitcoin.
They're not just playing games, they're securing the network.
So speaking of history, Calix talks about the Genesis block.
Ah, yes. The very first block in the blockchain.
The OG block.
The foundation,
Yeah.
Everything else is linked back to it.
Like a digital time capsule.
Exactly. With the very first Bitcoin transactions.
He uses a Python list to show this,
Yeah. New blocks added to the end, each referencing the previous hash.
creating this like immutable record.
And that's what makes it so secure.
Okay.
You try to change something in the middle.
Yeah.
The hash changes. All the following blocks are invalid.
Like rewriting history.
The network would reject it instantly.
So it's self-correcting, tamper-proof.
Exactly.
That's amazing. But how do we know, like, how much effort went into mining each block?
So Calix introduces this thing called nonce in the script.
Nonce.
It's a number that miners increment with each attempt.
Oh.
The higher the nonce, the more work went into finding that hash.
So it's like a measure of their effort?
Yeah, the processing power they used.
Makes sense. So how does Bitcoin actually move through this whole system?
Okay, so at its core, a transaction is moving Bitcoin from one wallet to another.
Right.
But here's a weird thing. You actually empty your entire wallet balance.
Wait, what?
Yeah, it sounds strange, but it's how it works.
Okay.
You send your whole balance as input,
Okay.
part goes to the recipient, the rest comes back to you as change.
Like if I paid for coffee with a $10 bill
Exactly.
and got 5 back.
Same idea. It ensures every Bitcoin is accounted for
Okay.
and that the history is transparent.
That's a key part of blockchain, right?
Absolutely. Every transaction is public record.
Anyone can trace it.
Makes it really hard to hide anything shady.
Wow. So now it gets even more interesting.
Oh, yeah.
Calix says Bitcoin has this like built-in scripting language.
Right. It's not as complex as like Python or Java,
Okay.
but it can define the rules for how Bitcoin is transferred.
Like instructions.
Exactly. And they're written using these opcodes.
Uh-huh.
And the miners actually run these scripts to validate everything.
So before a transaction is added to the blockchain,
Yeah, they check if it follows the rules.
he gives some examples like OPDUP,
Mm.
OPHASH, OP equal verify
Yeah, those are like the basic building blocks.
for creating more complex logic.
Exactly. And that's where the real power is. You
Uh-huh.
can make smart contracts, multi-signature wallets, all sorts of things.
It's like programmable money.
In a way.
And it's all running on this decentralized network.
adds another layer of security.
So we can't forget about digital signatures either.
Oh, right. Like a digital fingerprint for each transaction.
Calix says it uses this algorithm, ECDSA.
Yeah, elliptic curve digital signature algorithm.
Same math as wallet generation.
Yep. It ensures only the owner can authorize a transaction.
That's pretty neat.
It is. And Calix even shows the code for it.
So we've covered mining, the Genesis block.
Scripting, digital signatures.
This is a lot.
We're almost there, though. In the final part, we'll put it all together.
Can't wait. It's mind-blowing, really. all this complexity
Yeah.
just to make Bitcoin work.
Calix did a great job explaining it all, though.
Yeah, those Python examples were really helpful.
Sure.
And I like how he brought it back to the real world,
Mm.
like those laptops overheating
Yeah.
really shows you the power needed to keep this whole system going.
And it makes you think about, like, the future of mining, right?
Yeah,
As the difficulty goes up, you need even more powerful hardware.
it's almost like an arms race.
Kinda, yeah.
But okay, big picture time.
All right.
What does it all mean? This decentralized system, transactions secured by cryptography.
It's a totally different way of thinking about finance.
Yeah.
We're so used to banks, centralized institutions.
Right.
But with blockchain, the trust is in the network itself.
In the math, the code,
Exactly.
and some of the ideas are so, well, counterintuitive.
Like what?
Emptying your whole wallet with each transaction
Oh, right, yeah.
to make it more secure.
But it works.
It does. And then the scripting language.
Yeah, that's where it gets really interesting.
Smart contracts, programmable agreements.
It's like beyond just money.
Yeah, like what other applications are there?
That's the exciting part. We're just scratching the surface.
Calix only touched on, potential problems, though.
Right. There are always risks.
Security's huge.
And sustainability with all that energy use.
What about, quantum computing?
Oh, yeah, that's a whole other challenge.
It feels like it's constantly evolving.
It is. That's what keeps it interesting.
So what's the takeaway for our listener? They've learned a lot today.
They have. This was a good deep dive.
Where do they go from here?
Keep learning. There's so much more to explore.
Explore, experiment, engage.
And most importantly, stay curious.
Yeah. Ask questions. Challenge what you think you know.
Who knows? Maybe you'll invent the next big thing.
Thanks for joining us on this deep dive into the world of Bitcoin and blockchain. Keep those digital minds buzzing.